Good morning once again. Today we're going to continue our discussion on time value of money. So let's just have a quick review of what we have discussed so far. So last time what we did was to compute for the determine whether a particular project or investment where you have uneven stream of cash flows. So this is not an annuity. So how do we determine whether this project is feasible or not? We said that we cannot add the cash flows belong to different time frames. So we either have to convert them into one time frame. So the most common one is to get their present values and then add the cash flows pertaining to the present values. And then we said that if the sum is called the net present value. And if the net present value is positive, then the project is okay. So what we did was to use the PV function. And we know that 9,000 today, the present value of that is 9,000 also. 1,000 after 1 year is equivalent to 909.09 if the rate of return or interest rate is 10%. And so we were able to get the other cash flows. And then since this cash flow has a negative and positives, then we segregate the sum of the negatives and we call it the present value of your cash outflows. So this is the summation of the present value of your cash outflows. And since it's only one, then 9,000 here. On the other hand, we have the present value of your cash inflows. So we added all of this, okay, and we got 10,652.59. And then we netted the two amounts to get 1,652.59. Since the net present value is positive, which means that the present value of your inflows is greater than your present value of your outflows, then the project is feasible. Okay, may I ask you guys if we solve this? Sorry, I'm getting confused with this section and the others.
Yes po, sir.
We did. Okay. Okay, so let me just write that. Okay, so what we did by way of review was to get the future value, right? Because we can also peg it to not to the present value, but to the future value. So since the project ends at year 5, then we can peg it the future value at year 5. Then the rate is, we use WACC, which is this one, and then Npr. Npr is we have to use this and then fix this, right? Since we're going to copy down, okay, we're going to copy along column E. We don't need to fix column B, since the way we're going to copy the formula here is going down. So it's the rows that will change, all right, and not the columns. So we're only going to fix the row, okay, and then we're going to subtract that from year 0. So this becomes 5 minus 0. If we copy this down, 5 minus 1, 5 minus 2, which gives us the correct Npr. And this is not an annuity. These are individual cash flows. So the present value is this amount. Okay, and I'll ignore the type because this is not. Okay, and then I'll put here negative. Okay, so the future value of 9,000, which is now, after 5 years at 10%, it will be equal to 14,494.59. And then I copied this down. Okay, so these are now your future values. Take note, the future value of 5,000, which happens also on year 5, is also 5,000. Kasi same time yan, no? So if we we can write here, can just copy this and replace this by net future value. So the net future value is equal to We're just replacing the P with F. Okay, it's the future value of your cash inflows minus the future value of your cash outflows. So the future value of our cash inflows is just the sum of this amount. So it's equal to sum of these ones. These are all now your future cash flows. E56, E60. Yeah, that's correct. Okay. And then for the, this is future value. All right. And if we sum this up, alt equal to getting 2651. This is our net future value. Okay. Any questions, guys? So whether we peg it at the present value, which is the more common practice. So we look at the present value of our uneven stream of cash flows. Okay. And then we can now add this because these are the present values. And also this one, we can also add because these are future values. In fact, class, if we are able to get this, we can project this, we can compound this up to year 5 to get this. So just to illustrate that, so I'll have negative FB, and then the rate is your WACC, comma, the NPR is 5. I'm going to get the future value of this. It's not a PMT, but rather it's a one singular cash flow. And the equivalent of that is 26151. Okay, so these are now your equivalent cash flows. So this one, this whole cash flow is equivalent to 1652.59 now, which is also equivalent to 2661.51 after 5 years. Okay, so I hope you get the meaning of this. And we also said that if the net present value is positive, then the project is feasible. And another way to look at it is your IRR. So let's follow the syntax. The values are this one. It's not the transformed present values. And then ignore the guess. And we get 15.47 as your internal rate of return. And we said that this is feasible since the weighted average cost of capital is only 10%. So you're earning the returns of the project is higher than the cost of obtaining capital. Okay. Oftentimes, NPV and IRR agree as far as the result is concerned. But in the event that there's a conflict between NPV and IRR, so for example, NPV says the project is okay, then the IRR says no, reject the project, then what should we do, class? What do you think? May conflict si NPV at saka si IRR. Si NPV, positive siya, which means the project is okay. IRR, on the other hand, is less than your weighted average cost of capital. Okay, therefore, what should we be doing? Anyone? Okay. The decision, class, is that if there's any conflict, let me just write that. If there is any conflict between the results of NPV and IRR, the NPV results always, okay, always prevail. Okay, so just remember this. If there's any conflict between the results of your NPV and your IRR, it is always the NPV results that prevail. Why is that so? I will not go into the theoretical explanation so much, but suffice it to say that the NPV is a more theoretically sound approach. Okay, theoretically sound approach to problems like this. Okay. All right. So let's move on. And this time we're going to look at non-annual compounding periods. Okay, when an interest rate is given, the assumption is always that this is an annual rate. Okay, but sometimes we will be informed that the interest, for example, is compounded semi-annually, which means 2 times a year. So if the interest is counted twice a year, then that means its future value will be higher. Okay. All the more if the interest is compounded quarterly, then the future value will now be higher because there are more times the interest is compounded. If it's bi-monthly, 6 times. So if it's daily, guys, 365 times. So excluding the perpetuity among this, from the perspective of an investor, daily compounding is the best because every day your interest earns interest. Okay, so there will be difference between the future value, and as such, there will now be a difference between your what we call your effective annual rate. Since comparing an annual and a semi-annual mode, the semi-annual will have a higher future value. Therefore, its effective annual rate, which is EAR, will be higher also. Okay, so we're now going to this concept of effective annual rate, and this happens when the compounding is other than annual. Okay, we're given the annual rate 30%. Okay, and then 30 years to invest. What we're going to invest now is 1 million. The question is, how much is this after 30 years if the compounding is annually? How much is it if the compounding is semi-annual? Okay, so as an exercise class, why don't we do this? So let's give this a name so that it will be easier for us. Okay, let's give this a name. I'll copy everything. I'll highlight everything. And you know the drill, guys. We should press Control Shift F3. Okay, and Excel guesses that your left columns are your names. Okay, And let's see. Notice that the names are annual underscore rate, present underscore value, because Excel does not accept names that have spaces. So it automatically renamed this as present underscore value, annual underscore rate. Okay, take a look at this. See that? Annual underscore rate. And this one is years. Okay, so for this one, it will be very easy to compute for this. Okay, but I want us now to put a formula here so that we can cut it down daily. Okay, using the present value, the annual rate, and the years, I want you now to compute for the future value. For annual, the number of compounding, the frequency of compounding is only once a year. For semi-annual, 2 times every 6 months, you compound the interest. Quarterly is 4 times, bi-monthly is 6 times, etc. Daily is 365 times, weekly is 52 times. So the more frequency, the greater the frequency of compounding, the higher will be the future value. Okay, so let me pause share. I'll give you a few seconds, few minutes. Pause share. First, I want you to tell me in the chat box how much will be the future value for annual, and then comma or semicolon semi-annual. Okay, so let's do that. It's an exercise. Let me pause share. By the way, use the FB function of Etsy. Waiting for your answers, guys. Kindly chat 2 numbers. One is how much will be the future value if the compounding is annual, and then comma, how much will be the future value if the compounding is semi-annual. Okay, we have some answers. Okay, thank you, Patricia. 17 for pareho lang, Patricia. Same answer. Okay, hint, guys, clue. the semi-annual will be bigger. Kasi 2 times ka magko-compute ng interest. So if you're comparing annual and semi-annual, the future value of your semi-annual will be higher. But your annual is correct. So thank you, Patricia. The annual future value as far as Patricia is concerned, 17,449,566. That's correct. Okay, and then kindly 449. Oops. Sorry, may hindi pa wala, no? 17,449. I'm getting a different number. I'm not getting 566. I'm getting 402. 17,449, 402. So yeah, kindly check na lang, no? And then for semi-annual, it should be bigger. Okay, let me just flash the screen. Okay, so that's your hint, guys. Who got semi-annual 18,679,185? Anyone? Okay, sige. Fiona, may I request you to please Fiona, can you please share your screen and kindly explain to the class how you got the 18,679,185? Hello, Fiona. Is it okay for you, Fiona, to share your screen and then share to the class how you got the value the same as mine, 18,679,185? Hello? Okay. Thank you. Anyone else who got the same answer? Anyone else who got 18,679,185? Any volunteer? Okay, but definitely you got 17,449. Who got 17,449 for O2? By now, guys, you should have gotten that. That's very simple. That's what we have been doing so far. Okay, anyone? 17,449 for O2.27. Hello, guys. The rest? Yes, Gerard. So, Gerard, could you kindly share your screen, please? Thank you, Gerard. Okay, great. Sige. Gerard, can you kindly lessen, decrease the width? Go down. Yeah.
Yes, sir, what?
Decrease the width. Masyadong malaki.
Like
Go
that?
to, hindi. Go to column C. Between yung header mo, column C and column D. Sige, to the right. Column C, yan. There. Sige, yan. Sige, then, yan. Sige, go. Go, sige pa. Yan, sige pa. A little more. Okay. So, can you kindly increase the size of your yung sa screen para dito sa ilalim, lower. Sige. One more. Okay. Sige, just one last. Yan, okay. And go up a bit. Okay, could you kindly explain how you got 17,449?
Say just put in the formula.
Okay. FV. Okay.
FV, annual rate, years, and present value.
Okay. All right. Thank you. Sige, enter mo. So let's use this worksheet, Gerarda, to discuss yung susunod. No? Okay. So that's our formula. Now we want our formula. We just want to use one formula and then copy the formula down up to daily so that we get yung semi-annual, quarterly, bi-monthly, etc. Okay. Now, semi-annual, how many times are we going to compute for the interest? Anybody? Or Gerard, you can, if you wish to answer. How many times? Semi-annual. How many times?
Twice.
Yeah, twice, no? Twice. So each time you compute the interest, what will be the rate to be used? Anyone can answer, please? Just unmute yourself. For annual, we compute the interest once, and the annual rate used is 10%. For semi-annual, we compute the rate twice a year. How much will be the rate to be used? Guys, so that's very easy. Anyone? Okay. Patricia, 20%. So pag mag-20, if we use 20%, so we compute 20% once, and then compute 20% again. So if we add that, that will be 40%. Okay. But thank you for your answer, Patricia. However, if we use 20% once and then 20% again another time, that will total 40%. So I think the answer of Patricia will give us now a clue. Okay, let me repeat my question. For semi-annual, we compute 2 times. The question is, what rate are we going to use when we compute it 2 times? So Patricia provided an answer, 20%, and I explained why it's not so. So can you now answer me, guys, class? What rate are we going to use? Okay, may nag-chat ba? What rate are we going to use? 10.25, 20. Okay, any other answer, guys? What rate are we going to use? Gerard, ikaw. What rate are we going to use?
Is it 5 then?
Why 5?
Because if it's gonna double, then it should be 10.
Yes,
Or-
correct. Yeah, that's correct. So if it's semi-annual, we compute twice. However, the rate should be divided by 2, right? Because 5% first, and then another 5%. If you add that, that's actually practically 10%. Okay, so that's the clue. Right? Now, how many times are we going to compound with semi-annual? Answer, class. How many times are we going to compute the interest or going to compound with semi-annual rate? The answer is, it's there, guys.
Twice.
Yeah, twice. Yeah, correct. Thank you, Diana. And for quarterly, how many times are we going to compute the interest? 4. Yes, now you got it. No? For quarterly, how much will be the rate to be used? Yeah, thank you. Thank you, Shiler. That's correct. 2.5%. Okay, because if you're computing 4 times, so 2.5 first, and then another 2.5, another 2.5, another 2.5, that gives us 10%. Okay. All right. Thank you so much, Gerard. Okay, I'll get control of the screen again. Okay. Now, I'll give you 1 minute, guys, to come up with one formula here in the annual, copy down up to daily so that you get these values. Okay, once you get it, guys, kindly please chat yes so that I know who, if you were able to get the answer. Only one formula is needed. One formula and then copy down. And it's also a good thing that we already gave names to our givens, present value, annual rate, years. That will make it really very easy to compute for the other non-annual compounding. Only up to daily because you cannot, of course, copy the formula down up to infinite because that's a text, that's a word. And once you're done, kindly please chat so that I know the number of people who got it. So start first in cell C72. C72. You start the formula there and then copy down up to C79. No answers yet? Waiting for you to chat. Yes, if you got it. Let's see how many will be able to get the answers. Just one formula, copy down. just follow what the answers to what I was asking you a while ago. For example, for semi-annual, what will be the N per there? How many times are you going to compute interest? And then what should be the rate there for semi-annual? So if you keep that in mind and apply it to the formula, then you should be able to get it easily. I'm still waiting for the first one to chat yes. Okay, thank you, Christine. Yes, we have the first one. Christine, kindly prepare your screen. I'd like to request you to share your screen in a while, okay? Let's just give your classmates a few more minutes. Okay, still waiting, guys, for the rest. Just follow the concept. For semi-annual, there will be 2 times. And then your rate will be 5%. For quarterly, 4 times. No other hands yet, class? 1 more minute. I actually feel that you should you should be able to get that because you were able to answer my questions a while ago. For example, what rate will be used for quarterly? How many compounding will there be? So you were able to answer that. So just apply that in the formula. I'll give you 1 more minute, and then afterwards, we'll request Christine to share her answer. Okay, no other hands? No other hands? Okay. Right, let me stop share. Christine, would you kindly share your screen, please? Okay. Could you please increase the size? Ano mo na, zoom mo na lang. Sige pa. Okay, there. And then F2 please, F2 muna. Yan, sige. Could you kindly explain what you did here?
I divided the unread from the periods tapos I multiplied the years in sa periods.
All right, so for the annual rate, you're dividing the rate, which is 10% by 1. And then we are dividing it by the periods per year. Isn't it? This is what we did a while ago, guys. So when we go to semi-annual, it will become 10% divided by 2, right? If you divide the rate by the periods per year, then you'll be able to get the rate per period. So with this formula, that's 10%. If you go down 10% divided by 4, that will give us 2.5%, which is how you answered my question a while ago. So that will take care now of the rate. How about the years? What did you do, Christine, for the years?
Minultiply ko po sa period.
Okay. Punta ka nga dun sa years, yung mouse mo. Please go to years. Sa years mismo. Go there. No. To C77. And then press F2. And then your mouse put to the second one, years. Yan, there. Okay? So take a look, guys, at NPR. What will now be NPR? Okay, so there are 30 years, right? If it's annual, then that's 30 times 1. That means 30 periods. But if it's semi-annual, how many times will compute the interest be computed? Since there are 30 years, and then there are two compoundings per year, so that will be 60, because the number of years 30 times 2. Okay, so the more compounding there is, the more will be the number of periods. Okay, for example, if it's monthly compounding, then it will become 30 times 12. So the interest will be compounded 360 times. All right? And then the present value, we know there's 1 million. Okay, Control Enter nga, please, Christine. All right, and then could you kindly copy the formula down? Copy mo na lang ulit. Hindi. Wait. How are you copying? Go yan sa cell na, go to the lower right. And then go to C77. How did you copy that formula? While
Sir, what do you mean po for
how did
copying po ng formula?
kindly erase C78 hanggang C84. Erase that. Delete that. Sabay-sabay mo nang i-ano. Yan, delete mo. Lahat. Highlight everything and then delete. What isa-isa lang.
Sir, di rin po sure, pati isa-isa lang.
Highlight mo nga, yan, delete mo. Kasi kasama yata yung, hindi, sige, yan, sige, delete mo na lang lahat. Okay, how did you copy that down? Yun lang naman sinasabi ko kanina. Copy it down. All right, so go to C78. Let's see the formula there. C78. C78. F2, please. Okay, so our formula now. Okay, please go to the annual rate, please. Yung mouse sa first parameter. Sa rate. Hindi, sa unang-una. Yan. There inside there. Okay, rate, no? What will now be the rate? The rate is your annual rate, 10% divided by 2. So that covers now 5% na lang siya, di ba? And the number of years is 30 years times 2. Bakit 30 years times 2? Because every year there are 2 compounding periods. Okay, so since there are 30 years and 2 compounding periods per year, so that should be 60. 60 periods of compounding. And then kindly go to the last one, 84, please. C84. F2 again. All right. Didn't the formula just follow? So for the rate, it's 10% divided by 365. Okay, because the compounding will be divided on a daily basis. And then the years, the number of periods will be 30 times 365. Okay, so thank you so much, Christine. Okay, paki-enter na yan. All right. Okay, so back to my question. Back to my question, please. How many among you got the answers? Please. I'm waiting for your chat, please. Okay, thank you. Thank you. Yeah, very good. Very good. All right. Okay, so that's how you go about it, guys. So you have your, if the compounding is not annual, which means it has to be defined. So for example, semi-annual compounding. So the rate that will be given you is the annual rate. It will give you 10%, but this is to be compounded semi-annually. Oh, it means that there will be 2 compounding periods, but the rate per period will be 10% divided by 2. So that's 5. Okay, so I hope that's clear. We were able to, with one formula, we were able to compute for the future value for annual compounding, semi-annual, until daily compounding. Okay, now how about this? What if it's infinite compounding? So there's such a thing as infinite compounding. How do we now compute for infinite compounding? Okay, so for infinite compounding, we use this formula. So that's PV times okay. So this is the formula for continuous compounding, or what we call perpetuity. Okay. How much? Chat, please, if you have met this number E. Yes or no, please? I would appreciate, dali lang guys, I would appreciate you informing me. Have you met this number E? Okay, thank you. Good. Thank you so much for your honesty. Okay, E is, I'm sure you have met pi, no? Si pi. Si pi is equal to pi. So pi is, you have learned this in your elementary, your high school. It's 3.14 yung estimate, no? But actually, pi is a non-repeating, non-terminating number. Non-repeating, non-terminating number siya. It means that if you can use a very powerful computer and then generate the actual number of pi, okay, you can use a bond paper, use font 1, if that's possible, and print the answer to pi back to back. You will have a stack of bond paper reaching to the moon and back to the moon and back, etc. And the number pi has not stopped. Because it's a non-repeating, non-terminating number. In the same manner, this one, which we call Euler's number. This is called Euler's number. The exponential, okay, E. Okay, E on the other hand, in Excel is equal to, we use EXP. So this means EXP 1 means E to the 1. Okay, that means E. Okay, E to the 1, or simply E. Okay, and that's 2.7, 18, 28, 18, 28. And it's a sister number of pi, which means it's non-repeating, non-terminating. Okay, so if I continue this, Excel will only print it up to how many digits? I think 15, but it's just like pi, it's non-repeating, non-terminating. Okay, so we use this Euler's number, or E, in order in continuous or infinite compounding. So let's do that. So this is equal to the present value, okay, multiplied by, oops, present value, then multiplied by, then we're going to use the EXP function, EXP, okay? So this is the exponential, and it's raised to the RT. So RR is your annual rate, and then your time is your year, right? Years. Okay, so that will now be our formula. And as expected, your continuous compounding or your perpetuity or infinite compounding will of course be higher even than your daily compounding. Okay, so that's now the present value multiplied by E raised to the RT. That gives us 20,085. So it's higher than the daily compounding. Of course, you might think not much of a difference, but because our present value is only 1 million. But if we're considering, for example, if you're looking at, for example, tens of billions, so this is 10 billion. This is 10 billion. Okay, you can see now the difference. Okay, if it's semi-annual, if it's annual, 174 billion. But if it's continuous compounding, 200 billion. So a difference of 26 billion. Okay, and comparing daily and continuous, so the difference is, let me just subtract that. Oops. It's a difference of 82 million. Okay. Okay, let me pause for a while. Any questions about the different compoundings? You have annual, semi-annual, quarterly, 4 times a year, bi-monthly, monthly, bi-weekly, weekly, daily, and you have the continuous compounding. Kindly chat, please, class, if so far the computations for non-annual compounding is clear to you. Okay, good. The rest? Okay, thank you. So waiting for the rest for their feedback. Okay, thank you so much. Okay, so far what we have done was we learned how to compute that using the function in Excel, the FP function. Now, what if we're using a formula? For example, we're using a calculator. So take a look at this. I wrote the formula here. The effective, okay, sorry. So given this future value, now we'd like to compute for the effective annual rate. Because the nominal annual rate, this is called the nominal annual rate. It's 10%. However, you have another measure called EAR, effective annual rate. And based on the future values, you know that the effective annual rates will be different. Because although they have the same present value, okay, let me go back now to 1 million. Although the present value is the same, 1 million, and then the future values are different, therefore, the rate, of course, will now be different. Okay, the rate will be different. So let's first use the formula. Okay, the mathematical formula is that the effective annual return is equal to 1 plus your rate divided by the periods per year raised to the periods per year. Okay, so the formula is 1 plus the nominal rate divided by the periods per year. So that will give us the nominal rate divided by the periods per year. That will give us the number of the rate of compounding, the rate per period. And then we raise it to the periods per year. How many periods? How many periods? Okay. All right. So we can now use that formula. Is equal to, so this is 1 plus our nominal rate is your annual rate. So So that's your annual rate, right? And then we divide by how many periods, how many compounding periods per year. This one. Okay, so that's your 1 plus the nominal rate divided by the periods per year, and then we raise it to the periods per year. So this is the PPY, the periods per year. All right. So if we get that, okay, so sorry, may kulang formula, no? Apologies, this should have, okay, where's the comment? Edit one. There should be a -1. Okay, just kindly include -1. So there should be a -1. All right. So the effective annual rate for an annual compounding is the same as nominal rate, 10% din. Kasi the compounding is just once. Okay? The effective annual rate, if we're using annual compounding, will be the same as nominal rate. Okay. But when we go here, all right, now for semi-annual, the effective rate is actually 10.25%. And as you copy this, okay, so notice that the effective rates, of course, let's increase the decimal point. Okay, the effective annual rate becomes bigger, okay, if you have a non-annual compounding. Okay, as you can see, the future values are bigger if you have more compounding per year. Therefore, we expect that the effective annual rate will be bigger. Okay. All right, so that's the formula. Now for this, guys, okay, so let's take a look at this. For infinite compounding, let's insert a note. Insert. You note? Okay, you note? So the effective, the EAR here is equal to E to the I, E to the rate, okay. So E to the rate -1. So let's do that. Exponential to the rate, our rate is annual rate, okay, -1. Okay, as expected, for the continuous compounding, the effective annual rate will be higher as compared to daily. And the daily, of course, will be higher compared to the other weekly, bi-weekly, etc. Okay, let me pause for a while and then ask for your feedback. So far, class, clear? Clear to get the effective annual rate using the formula? Kindly chat, please, yes or no? Daniel, kindly share your question to the class. Okay, there's a question here. Daniel, kindly share your question to the class so that they know what you're answering. Hello, Daniel. Okay, so repeat natin kung continuous compound. So we said that the formula here, effective annual rate is equal to e to the r minus 1, where r, of course, we know is the annual rate. Okay, so that's a formula, e to the r minus 1, so f2, so e, this is your e, exponential, and then r, the annual rate, minus 1. Okay, Dan, did that answer your question? Okay, good. Thank you. Thank you for that question. Okay. Any other questions, class? All right. So no more questions. Okay. So we learned how to get that using using the formula. But we know a function, guys, the rate. But we can use the rate function because we have the future value and we have the present value. So rate. Okay, n per natin. What's our n per? Okay, our n per should be the number of years and then multiplied by 1, di ba? Ganun ba to, class? Okay, let's see if we will get the correct answer here. Okay, comma, PMT is PMT is ignored because that's not our PMT. Present value is our present value there. And then what's our future value? Okay, let me give you 1 minute, guys. You should be getting the same answer as the formula. Okay, I hope you got that, class. Once again, guys, feedback. I'll give you a few seconds to chat if you were able to get the rate correctly. Yes, yes. And then we'll entertain questions if you were not able to get it. You should get the same answer. Waiting for your responses, guys. Yes, if you were able to get it. Taking some time, guys. Huh? Very simple lang yan, using the rate function. One formula here, copy down. One formula, then copy down. Guys, what difficulty are you encountering? Okay, let me ask my volunteer, please. Okay, let me see. Let me request you to share your answer. Okay, Dan, ikaw na lang, Daniel, please. I'll stop share. Are you following along? Can you share your screen? I wonder why you're not, the whole class, that's what I meant, is not able to get the answer to the using the rate function. Hello, Dan.
Sir, mine keeps saying yung ano, may error po siya, yung
Sige
like
lang.
no.
Sige, share, paki-share. Let's see. No? Let's work on it. Paki-share Dan yung screen mo. Ha? Ayan, okay. All right. Sige. Go to that cell, yung may tapos F2, please. Paki-ano muna, Dan, paki-increase yung size, paki-zoom muna. Yan. All right. So tama, we're using the rate function. Okay, we have to understand class years times B72. Okay. Tapos kulang yung syntax mo. Go to years B72. Yung mouse mo ipasok mo sa years B72. Yan, so that's your NPER, di ba? And then your PMT, wala. Present value. Tapos, asan yung equivalent mo? Dapat may equivalent cash ka dyan. Kasi you're asking, di ba mag-error talaga tayo dyan? Kasi sinasabi mo kay Excel, you're telling Excel, what's the rate if my present value is like this? So how will Excel know what's the other value? You have to give another value. If you're looking for the rate or the NPER, you have to give at least two values. right? So ano yung what's the next to present value? Done. So go to present value dun sa formula mo. Sa formula. And then you have to comma at the end. It's future value. So you have to give the future value kasi you're asking our Excel to determine the rate. So there has to be two cash flows there. May present value ka, and then what's the future value? Yeah, sige. Okay. Enter mo nga. Okay, ulitin natin. Ba't nagna-number sign? F2 ulit. So first is and punta ka ulit sa years times 72. Okay, that's N per, right? N per years times B72, and then comma no PMT, present value, future value, type ignore, guess ignore. Okay. Present value. Okay, sige, enter. All right, guys, bakit nag-error? Anyone, please? You know this, guys. You know this. You know the answer why it's okay. Thank you, Selena. No? Remember, tama. Very good, Selena. Thank you so much. Remember, guys, Excel is very particular about the direction of the cash flow. So if you're dealing with two cash flows, one of them must be a negative, either the present value or the future value. So I choose one. Okay, enter. All right, copy down. Okay. So is there something there that you need to fix? Okay, and it's also giving us 5%, 2.5%, which is what? This is the rate per period. Okay, so let's understand the problem. Can you draw there? Sige. Thank you, Dana. So let me take control of the screen for you. Okay, so let me share screen again. Okay. First, we must understand the problem. Okay. Let me just draw. Okay. Na lang. Okay. So what we're actually contemplating of is you have here a timeline. Okay. So this is 0. This is 30. You have a present value here of 1M. Right? This is 1 million. And you have a future value here of this one. This is our FP. We're simply asked for the rate. So ito lang class yung cash flow natin. No? You have 1 million, then you have your future value, and then you have 30 years here. Okay, so that our so we're just getting the effective rate. So rate, okay. Our N per is this time we'll use 30 years. Because if we're going to use 30 times 1, then it will give us back to the nominal rate. Okay, so we're just using 30, and then what's the PMT? None. Present value is 1 million. It's a present value, comma. Future value is, I have to use a negative and this one. Okay, so I have a future value, I have a present value, I have years. So we're asking what's the effective annual rate. And then if I drag this down, in fact, we can also use the continuous kasi may value naman siyang, it has a value of future value. All right, so we have here now the effective rate using the rate function. Just understand that the problem that the time flow is 1 million at the start, the future value at the end, and then you have a particular rate. All right, so this is what we get, guys, and it's the same as the formula. Okay, any questions? Clear so far? Okay, good. How about the rest, class? Kindly chat, please, if it's clear so far, so that I know that you're getting me. Okay, good. Thank you. How about the rest? Yes? Okay. All right. Lastly, we have also a function in Excel called effect function. So if I type effect, so here, returns the effective annual interest rate. So this is very easy to use. You're just asked for the nominal rate. The nominal rate is your annual rate. Okay, I'm using the name so that we don't have to fix this. And then the number of periods per year. So this one, right? So that's the effect function. So it will do the computation for us. Okay, so let's just copy this format here. Okay, so using the effect function, okay, there. We can't use the continuous because the number per year is text here infinite. Okay, so very easy with the effect function. Okay, once again, guys, just to recapitulate, when you have compounding that other than annual, which means it can be semi-annual, quarterly, etc., then your future value will be bigger, of course, because you're computing more than once per year. Okay, but take note, the rate per year will be the annual rate divided by the periods per year. So if it's semi-annual, the rate that you're using is 10% divided by 2. Okay, not 20, not 10%. Okay, and then, however, the number of periods will now increase. Okay, if it's annual, there will be only one compounding per period. If it's semi-annual, 2. So if there are 30 years, so there will be 60 years, 60 periods, 60 compounding periods. For quarterly, there will be 120 compounding periods. But the interest will be 10% divided by 4, so that's 2.5%. So each of the 120 periods, it will accumulate 2.5%. Okay, so we were able to get and prove that the future value indeed is higher if the compounding is more than once. And then we also learned how to compute, several ways to do it. To compute for the rate, the effective rate, you can either use the formula, or you can either use the rate function or the effect function, and they all agree. Okay, one thing of note here is that continuous or perpetuity, which is of course the highest we can get as far as the future value is concerned. And the rate is also higher than even the daily. Okay, several ways to compute for this. Okay, all right. So let's just recap. Let's just quick review. So we know now how to compound. We know how to discount. We know the formula for the term for compound rate and also the term for discount rate. We learned how to get the future value and the present value using Excel and using the formula. Okay, we learned how to get the present value, future value for a single unit of cash, and we also learned how to get it for an annuity. Okay, we said that there are two types of annuity: annuity ordinary and annuity due. We also learned how to compute for the PMT, the rate, and the NPER. Okay, and just be careful with the equivalent cash flows. Okay, and pay particular attention to what's being asked. Also, we learned to compute for the assess a project given an even stream of cash flows, which normally happens. Okay, and then we learned how to compute for this using the net present value, either the long cut, convert everything to present values, or convert everything to another point in time. Here we did the future value, and then we compare the cash flows, the total cash inflows vis-a-vis the total cash outflows. Okay, for net present value or net future value, if the net amount is greater than 0, then the project is okay. And then we also learned how to get the IRR. We said that the IRR is greater than the weighted average cost of capital, then the project is okay. And for today, we learned how to compute for the future value for a non-annual compounding. We learned how to compute for the effective annual rate. And we said that the effective annual rate will, of course, be higher for non-annual compounding as compared to the annual compounding. Okay, so for next meeting, class, what we're going to do is this one. We're going to learn how to amortize, do an amortization table. Okay, so let me just show. Let's just see very quickly. I have 1 more minute. Pag-ibig, amortization. Okay, calculator, let's see. So HDMF, yung Home Development Mutual Fund. Okay, you can, they give people access to loans to, let's see, kunyari, no, borrow for housing loan. Ano to? Click how much income, how much you can borrow. Okay, not this one. Calculator. Okay, mortgage calculator. How about this one? Okay, for example, you have you're loaning a house at 3 million. Say the down payment is 20%, which means your equity, you have to contribute 600,000, and you can loan only the 2,400,000 because 600, the 20% should be contributed by you. Let's say you're going to loan for 15 years and the interest rate is 10.5%. So your interest rate na yan, it varies. It varies. Depende sa amount, depende, it changes over time. Interest rate now is 10.5%. Okay, and then we can ask IBIG to show the calculation. By month because the interest is paid monthly. So if we calculate this, All right, so this is now the amortization schedule. Okay, so you borrowed October. This is an annuity ordinary, so the payment will be November. Okay, the total payment is, the amortization is 26,530. There will be a total of 180 payments. Why? Because this is 15 years times 12 months, so that's 180. Okay, and then the loan will be paid off October 2037. So next Friday, we're going to learn how to do this. Okay, so this is what we call an amortization table. Okay, all right, so it's already time. Guys, thank you for your time. Let me stop